Hello, in this video I want to tell you about collections in Java. Here you can see a hierarchy of Java collections, and on the top we can see interface iterable. Iterable is a Java interface that allows object to be iterated using the for loop, and it is a member of Java language package and defines a single method iterator which returns an iterator object. And this iterable implementing this interface allows an object to be the target of for statement. So we can use it as for each loop statement. So both collection and iterable are interfaces, and collection interface extends iterable interface. And thus we can use iterator for each of the collections. For example, we can see that interface list extends interface collection, and the same goes for each of the collections, queue and set. And list is divided into array list, linked list, vector and stack. The most common types are array list and linked list. And it is important to understand the difference between array list and linked list. From this picture you can see that array list allocates a contiguous block of memory to store the elements, whereas linked list allocates a new node in the memory heap for each element. Each array list instance has a capacity. The capacity is the size of the array used to store the elements in the list. As elements added to an array list, the capacity grows automatically. As you can see, array list works faster for random access and iterations, while linked list works faster for manipulation with data like insertion and deletion. And if we insert elements in the beginning of the array list, it works slower than linked list. A queue is a collection in which the elements are inserted from the end and removed from the other end, following the first in, first out principle, also known as FIFO. Set is a collection that does not allow duplicates. There are three main types of sets in Java are hash set, tree set, and linked hash set. Hash set does not guarantee the order of elements and does not maintain the insertion order and allows null elements. Tree set maintains the elements in a sorted order, which can be natural ordering or specified by a comparator. Does not allow null elements and is slower than hash set due to maintaining the sorted order. And linked hash set, it maintains the insertion order of elements, it allows null elements, and it is slower than hash set but faster than tree set. The map collection is an interface that represents a mapping between key-value pairs. It allows you to store and retrieve values based on a unique key. Hash map, this is the most commonly used. It stores the key-value pairs in a hash table, which provides fast access to the elements based on their keys. However, the order of the elements in a hash map is not predictable. Tree map, this implementation of the map interface stores the key-value pairs in the tree structure. The elements are stored in a sorted order based on their keys. Linked hash map maintains the order of the elements based on their insertion order. And there is also concurrent hash map. This is a thread-safe implementation of the map interface that is optimized for high concurrency. It provides better performance in multi-threaded environments than HashMap or TreeMap. Here we can create an instance of ArrayList and add elements 1, 2, and 3. And here we have already implemented toString method, and we can just print the ArrayList. Here we can see all methods for the ArrayList. ArrayList is resizable array implementation of the list interface, and it permits all elements including null. Here we can see methods, size is empty, getSet, iterator, and listIterator operations, and time complexity. And also each ArrayList instance has a capacity, and this capacity is the size of the array used to store the elements in the list. And also it is important to note that the implementation of list as ArrayList is not synchronized, and it not be safe for threads. And also we can print ArrayList using for loop. And for each, which implements iterator. And also we can change ArrayList to linked list. Here is our methods of this interface. We see nodes. Each node contains information and link to the next and previous nodes. So linked list can be represented as a list of buckets that contain information and link to another bucket. We can see bucket with 0 number, the first, second, and third. And conversely, ArrayList is order of elements starting from 1 and ending with 4. And if we need to add a new element, and we add a new element to ArrayList at the end, and at the end of linked list, ArrayList will work faster. But if we want to add a new element in the beginning of linked list or ArrayList, linked list will work faster and ArrayList slower, because we need to change the order of all elements that are going in order one after one. But linked list is stored in memory, not in this order. It may be stored in different parts of memory, and it is linked, so if we add a new element in the beginning, the change will not be made to all elements. And for reading elements, array list works faster because we already know the index of the element, and using linked list we should check every element to get to the element we need. And time complexity for array list would be constant. And for adding a new elements in the beginning, array list will have linear time complexity, while linked list will have constant time complexity. And at the end,